All right, for these next couple, we're going to use calculators, but we're going to also use a little bit of hand or like just math in our heads. So we're asked to figure out if these are continuous at the specified points. We're actually dealing with functions now. So number one, we have f of x equals 2x to the third plus 3x squared minus 10x minus 1, seeing if it's continuous at x equals 2. So first and foremost, let's just plug in x equals 2. So we have 2 times 2 to the third plus 3 times 2 squared minus 10 times 2 minus 1. Now this is 2 times 8 plus 3 times 4 minus 20 minus 1. Cleaning this up a little bit more. We got 16 plus 12 minus 20 minus 1. Well, 16 plus 12 is 28. Minus 20 is 8. Minus 1 gives us 7. So far so good. Now for the limit part. So the limit as x approaches 2 of this function f of x. This is where we're going to need to go to a calculator. Now I've already put this on Desmos, so you can use Desmos, you can use a graphing calculator, whatever works best for you. So I've already graphed it. Looking at this, when x equals 2, go up here, looking like we got both sides approaching the same part here. It's really kind of hard for me to get exact. Usually it'll let me jump to it specifically. But it looks like it's approaching about 6. Oh, no wonder. I have a typo in here. Let's fix that. So, looking at this, at x equals 2, we got y equals 7. So the limit as x approaches 2 of f of x, once I typed it incorrect, is also 7. As a result, since f of 2 equals the limit as x approaches 2 of the function, oops, that's a check mark. So therefore, the function is continuous at x equals 2. So again, if the output and the limits are the same, then they approach. Now, for let's do number 2 first, doing them in order. This one, we're going to have to figure this out. We got approaching this again at, it doesn't specify. We're going to be approaching at x equals negative 2. My apologies. So number 1, f of negative 2 equals, well, looking at this, we're going to have to plug that into the bottom one, so it's just negative 4. Now, number 2, we have to do the limit. Again, we're going to do this on a graph. I'm going to use Desmos, so we got the limit as x approaches negative 2 of f of x. Now, this one's a little harder to graph both on Desmos and on our calculators, but I'll show you what we can do. So, wrong direction. On Desmos, let me go turn this off. Let's go back to the basic. So this is what the absolute value of x minus 5 over x minus 5 looks like. I'm looking at the wrong one. Sorry. This one. This is what the x squared minus 4 over x plus 2 looks like. Now again, we're checking it at x equals negative 2. Now if I clicked on x equals negative 2, you'll see it says undefined. That's because if we plugged in negative 2, we get 0 in our denominator. But it's undefined there, but it's getting really close to what looks like negative 2, negative 4 from both the left and the right side. Now in addition to that, that second part there says, well, at that point, it is at negative 4. So the limit is negative 4, even though on the top part of that graph, it doesn't include that point at all. But again, since f of negative 2 is equal to the limit as x approaches negative 2 of the function, therefore it is continuous at x equals negative 2. The third example, f of x equals the absolute value of x minus 5 over x minus 5. So plugging it in to start, so step number 1, my apologies, f of 5. Plugging that in, we have the absolute value of x minus 5 over x minus 5. Well, that's 0. When we plug in 5, that's 0 over 0. So it does not exist. It just doesn't work. You can stop here. But to kind of further solidify it, I'm having a hard time writing it. To further solidify it, the limit as x approaches 5 of this function. Again, I'm going to go back to Desmos. Looking at that one, that is this one in the middle. Looking at this, as x approaches 5 from the left side, it's looking like it's down at -1, but from the right side, it's up at +1. So the limit also does not exist. So the limit does not exist. And as a result, even though neither of them exist, technically that's quote-unquote equal to each other, we're going to say it's not continuous. Oh, why is that writing weird? Continuous at x equals 5. It is not continuous at x equals 5.